Hi, I'm George Greco, Professor of Chemistry at Goucher College. We'll begin our study of chemistry by considering elements and compounds. So depicted on the screen are several chemical formulas and chemical structures drawn in a number of different ways that chemists draw structures. So to start with, let's try to consider what are these things anyway? Are they elements, compounds, atoms, molecules? Chances are these are all terms that you've heard of before, but what we would like to do as we begin studying chemistry at the college level is give them a precise definition. So the term element has actually been around for a very, very long time. We can go back to the ancient Greeks, as we can with many things involving science. And the ancient Greeks, of course, had four elements: earth, air, water, and fire. And the ancient Greeks actually thought that all substances could be produced simply by combining these four elements in the proper proportions. So, like many things about ancient Greek science, they were kind of half right and half wrong. They were right about producing substances by combining elements in the proper proportions. But what they were not right about is exactly what those elements, of course, are. Okay, so now I'll take you to some modern definitions. So an element is defined as any substance that cannot be broken down into simpler substances by any means. So there are currently about 120 known elements. A compound, on the other hand, is a substance that can be broken down into two or more elements. So the other terms that were on the first slide, an atom is the smallest particle of an element that can exist. Okay, so the ancient Greeks actually came up with the concept of the atom also. So in 300 BC, Democritus asked the thought question at that point: if you take a gold coin and cut it into smaller and smaller pieces, would it still be a gold coin, or would it no longer have the same properties as the whole? Okay, so then a molecule is a group of atoms linked together by chemical bonds, and elements contain one type of atom, although some of the elements, specifically hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, exist as diatomic molecules. Diatomic, of course, means there are two atoms of that element in the molecule. Okay, so let's go back to what we started with. What are these things? Well, carbon, sulfur, hydrogen, oxygen, they are all elements. We will meet many more of the elements as we proceed through this course. Carbon is an atom. And then the rest of the elements, sulfur, hydrogen, and oxygen, are actually molecules. So hydrogen and oxygen, as we already said, exist as diatomic molecules. Sulfur actually exists as a ring of 8 sulfur atoms linked together to form a molecule, and you can see a picture of that near the top of the screen. And then some compounds also exist as molecules. Okay, so carbon dioxide and carbon monoxide are both examples of compounds. And we have a couple of other different ways that we draw those structures down on the bottom of the screen. And both of these are called binary compounds because they contain just two elements. Carbon dioxide is also an example of a triatomic molecule, which simply means that there are 3 atoms making up this molecule. Okay, so something else that we need to know immediately as we start the course are chemical symbols. So instead of writing out the full name for elements all the time, we will frequently use a symbol for them, and the symbols are all 1 or 2 letters. So in many cases, for many elements, the symbols are similar to the name in English. So hydrogen is H, helium is He, the first two letters. Lithium is Li, carbon is C, nitrogen is N, oxygen is O, fluorine is F, neon is Ne, chlorine is Cl. We skip the second letter. But then, as you may know from just a little bit of chemistry you might have had before, in other cases, the symbols are not similar to the name in English. Okay, so sodium is Na, potassium is K, iron is Fe, silver is Ag, gold is Au, mercury is Hg, tin is Sn, tungsten is W, where did that come from? Lead is Pb. Well, I don't expect you to memorize all of these, but just in case you're curious as to where they've come from, some of these are names in other languages. So for example, the German word for tungsten is Wolfram, and that starts with the letter W in German, but many of these are actually Latin names. Okay, so natrium, callium, ferrum, argentum, aurum, hydrogyrum, stannum, and plumbum are all Latin names that go with those particular elements.